In this lecture, we will discuss about the Adagrad Optimization Algorithm. So here in earlier classes, we have discussed about the stochastic gradient descent optimization algorithm. So what is the difference between these two means? In stochastic gradient descent algorithm, this learning parameter is common for all the all weights as well as biases. But in Adagrad optimization algorithm, it is different for the different weights and biases. So here the definition, if I'm coming to the Adagrad algorithm, is the optimization algorithm that adapts the learning rate for each parameter individually. So here this especially it will use in the sparse data, because we had know that about the sparse data consisting of more some features are zero. So in those cases, if I'm maintaining the learning parameters common for every feature, that will lead to some problems and it will take time consuming. So instead of like this, some features we are which more important feature we have to increase the learning rate, and which is less important features we have to make the some smaller values of learning rate. So here uh, this, if I'm coming to the, it is used instead of single learning rate for all parameters. Adagrad adjust the learning rate for each parameter based on its historical gradient updates. So if I'm coming to the mathematical formulation, this is the updated equation. That is, let us, if you have taken that is weight, the new weight equal to old weight minus eta by gt plus eta epsilon into gt. So zeta is a here gt is a small gt is a gradient of with respect to weight or bias. We will see later in the problem. And here eta is a learning parameter, that is where we can take it from 0 to 1, and epsilon is to avoid the denominator become 0, and gt is here gt equal to old, that is gt minus 1 plus gt small gt square. So here gt is the sum of squares of the past gradients, and here gt is a gradient loss function at the time of step. And here what is the advantage of this algorithm is that it is effective for sparse data. So frequently that means where there is a important features were there, then we have to that is we have to increase the learning rate, where the infrequent if it is not necessary, we have to decrease the learning rate. And disadvantage of this algorithm is that it is aggressive learning rate decay. That means sometimes what will happen that it is if I'm increasing this learning rate more, then it is very rapidly reach to the our true solutions. That is a very aggressive. And here the example, if I am taking implementation of Adagrad for a simple neural network with one neuron, only one neuron we are taking, that x equal to 2, and weight plus a bias we have given, and we have to estimate the y cap. Actual output it has given, that is y equal to 5. For x equal to 2, we have to get the y equal to 5. So here we are substituting the y cap, that is w naught x plus b naught. W naught and x naught initially we have taken 0.5 and 0.1, and after calculating y cap we are getting 1.1. So if I'm substituting in the last, that is y minus y cap, 5 minus 1.1 means there is a huge difference, 3.9. Therefore we need to update this weight and biases to reduce this loss. So in order to reduce this loss, we have to go for the back propagation. So back propagation, here we are using the Adagrad mechanism, Adagrad optimization algorithm. So this one here with respect to the dou L by dou W, that is equal to dou L by dou y cap and dou y cap by dou W. So that the differentiation of this one is minus 2x into y minus y cap. So if I am substituting the following values, then I am getting minus 15.6. At the parallelly, the same dou L by dou B, I am getting the minus 7.8. So then update the gradient accumulator. Now it is a something different as compared to the stochastic gradient descent algorithm. There itself, how we are writing? We are writing W new equal to W old minus alpha into dou L by dou W. But here it is a somewhat modified formulas were there, because we need to place the learning parameter for each weights and biases individually. Uh, So therefore this formula arrived GW equal to GW plus dou L by dou W whole square. So GW initially we have taken 0 over here. And if I are substituting all the values, I am getting 243.36. Parallelly, gradient accumulator for the bias also we have calculated. Then compute the adaptive learning rates. That is a initial learning rate is a 0.1, and after substituting this one, the new learning rate will 0.00641. Now for the same we are getting for the bias also, that is a learning rate is a 0.01282. So here updating the parameters. Now that's the formula is slightly modified. In the earlier I said in the stochastic gradient descent algorithm, this is the fixed parameter, that is hyperparameter. Now this parameter has depends on the some other parameters, that is this G, B and GW. Okay. After substituting this one, I am getting 0.6, and bias I am getting the 0.2. So this is a new updated weight and biases. Again, if we repeat this process for more iterations, Adagrad will gradually reduce the learning rate, preventing large updates and allowing better convergence. That means if it is getting towards the true solutions, automatically the learning rate getting reduces to settle at the convergent place. Okay. So this is the procedure, and this procedure will repeat until the errors become zero, and that means loss it is might be negligible or becoming a zero. So this is the concept behind the Adagrad optimization algorithms. Application I said, application is when data is becoming sparse, then Adagrad optimization algorithm will perform well in manner. Okay, thank you. If you are liked the video, please click on the like button.